Hello everyone, this is Dr. Young, and in this video we're just going to talk briefly about how to name ketones. Right? First of all, remember that ketones are just a type of carbonyl compound where the carbonyl is attached to a carbon on either side. So it has to have a carbon on either side. It can't be a hydrogen or an oxygen or nitrogen. Those are different functional groups. So ketones, carbonyl, two carbons on either side. So when you want to name a ketone, right, you just take the alkane name that you'd normally give it and you change the E at the end of that alkane name to -one. So for example, right, we have 1, 2, 3 carbons here, so this would be propane. And if I want to name this molecule where I have a ketone, right, because I have a carbonyl with a carbon on either side of it, same thing. So it's still a prop, A-N, but instead of the E here, we put O-N-E. So we've changed the E here at the end of propane to O-N-E to own. So this would be a propanone. That would be the IUPAC name for this. Propanone, specifically 2-propanone, and we'll talk about the numbering in a second here. As a side note, this also has a common name, acetone, really common solvent, so acetone, A-C-E, acetone, like a nail polish remover or a really common cleaning reagent that we use in organic labs all the time. So also known as acetone, but propanone is the IUPAC name. Now, if you go down to these examples here, right, you want to keep in mind that the ketone is given the lowest number possible, right? So just like we saw with alcohols or alkenes or alkynes, if those are the highest, if those have the highest priority functional groups, you want to give them the lowest numbering possible. So here we have a ketone in the middle of this compound, and here we have one kind of off to the end of the compound. So these would have different names, even though they're both butanone, or pentanones. This would be 3-pentanone. Or you might also see pentan-3-one, because you can put the locant right in front of the actual functional group. Or you might hear this called 2-pentanone, because the carbonyl is at carbon 2. Or again, like I was saying, this could be pentan-2-one. And again, the second one is kind of what IUPAC is favoring right now. However, you're going to see 2-pentanone or 3-pentanone all over the place, and you'll hear teachers like me use that all the time because that's what we learned. I could do this example over here, right? Remember that the carbonyl has a higher priority group than things. So even if you're going to have really high numbers for other substituents, that doesn't matter. Keep the ketone as the lowest number possible. So we have 1, 2, 3, 4, 5, 6. I wouldn't do the numbering the other way around and have my ketone be at carbon 5 just because I want my fluorines to be 1s. The fluorines, halogens, again, have no priority whatsoever. So just go with the ketone, get that the lowest numbers possible. So in this case, we have a 2-hexanone and a 666 trifluoro. So this would be a 666 trifluoro, 2-hexanone. Or again, hexan-2-one, whichever way your instructor wants. I'll accept both ways. IUPAC specifically wants where the locant is in the middle. So that's how you basically name ketones. You just change the ending to -one and you say where the ketone is. I want to say one quick note, just to make sure of something here. You'll never see a ketone at the end of a carbon chain, so it'll always be like 2 is the lowest number it can be. You won't see it at the end of a carbon chain ever because that means that there'll be an H attached to that carbonyl and then it'll be an aldehyde. So you'll never have a 1 ketone anything. Now let's take a look at some other examples. So I've got my ketone, I've got 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 if I count that direction, or I could count the other way and call this 1, 2, 3, 4, 5. So you'll notice that either way, it looks like my, let me make this a little more clear. Either way, it looks like my ketone is going to be at carbon 3. So that's a tie as far as either one of these naming systems goes. So my ketone's in number 3 regardless, so that is out of the picture. Now I just care about my second highest thing, which in this case would be like the alkyl groups or the halogens. So in this case, I'm going to go with the green route. The green route is the correct numbering, so I'm going to go with the green route is correct because it's going to give me lower number substituents for my methyl and my bromo than the red route would. So this will actually be a 1-bromo, 2-methyl, 3-pentanone. And again, with the red route, if I started from the left and went to the right for my 1, 2, 3, 4, 5, I still would have gotten a 3-pentanone, but then I would have had a 4-methyl and a 5-bromo. Those are higher numbers than I could have gotten, so I'm going the green route, 1-bromo, 2-methyl. If I go over to this other molecule here, here's definitely my hexane, my ketone is over here at carbon number 2. This is carbon 1, 2, 3. I have to go the longest route, so 4, 5, 6. So it's a 6, hence the hex. And it looks like I have a T-butyl group coming off of 3, and I have my carbonyl coming off at 2. So if I name that one, I should have a 3-tert-butyl, 3-T-butyl. You could write tert or T, whichever way you want. And then 2-hexanone. 2-hexanone. So again, you follow the same sorts of rules. The longest parent chain is the one that you want. The longest parent chain with that functional group. We can have cyclic things, that's totally fine. You can have cyclic compounds. Just like with the alcohol example, if you have a cyclic compound and you have a ketone on it, make sure that that is your number 1, since that's your highest priority thing. It should be number 1. And then you just go either clockwise or counterclockwise from there so that you have the lowest number for your first substituent. In my case, I just have a methyl, so I'm going to go clockwise from here. So I have a 2-methyl, not a 5-methyl. So 4 and 5. And in this case, I have a 2-methyl. 2-methyl. Now this is cyclic, so I have to say cyclic. So 2-methyl cyclopentanone. Cyclopentanone, right? So it's cyclic, so I put the cyclo in there, and then I change the ending also. You'll notice that I didn't put a 1 in there, and that's because if you don't need to put 1 if it's a cyclopentanone. It means that it's at the 1. If you want to put a 1 in there, that's fine, but you just don't need a 1. It can't be anywhere but the 1, since because it's a ketone, that's the highest priority functional group, that's what you named 1. So anyone would know if you drew a cyclopentanone, people would say, oh, cyclopentanone, great, that's this. And if you said it's a 2-methyl, they're just going to go, oh, okay, great, I'll put a methyl there. And that's all the information you need to know to draw it. So the 1's redundant, you don't need to put it there. What is important that I did not put on here, though, is the fact that this is a stereocenter. So I need to make sure this is RS. So in this case, it looks like we have an S, I believe. All right, this should be my highest. This should be my second highest. That should be my third highest. My lowest priority group is an H, which is in the back. So it looks like counterclockwise to me, right? Because O beats C, and these C's beat these H's. So I think we're good. So it should be S. And then with my last one real quick here, definitely the ketones hanging out more to the right-hand side. So 1, 2, 3, 4, 5. So then if I take a look at this, right, I have an iodo and I have an ethyl. So this would be a 3-ethyl, 1 iodo, and then I have 5, 1 iodo, pentan 2-one, right? Because the ketone shows up at carbon 2. So I have an ethyl at the 3, iodo at the 1. There's 5 carbons, so it's pentan 2-one, right? Pentanone. And so that's how you would name some of these. Lastly, let's take a look at a couple more complicated examples. So aldehydes and ketones have higher priority groups than alcohols or alkenes or alkynes. So if you have 2 of those functional groups in the same thing, you're going to go with the carbonyl. You're going to go with the ketone. So that means even though I have an alkene in this one, I'm just going to kind of ignore it as far as numbering goes and make sure that my ketone has the lowest numbering possible. So I'm going to start from the left and go to the right. So 7, 8, 9. So now I've got the longest chain with both of those functional groups in there, but I've given the lowest number to my highest priority thing because ketones beat alkenes. So ketones have a higher priority. That should be my lowest priority group. And then from there, you just start naming what's on here. So in my case, I just have a 6-methyl, really. So I'm going to say, let me back up a little bit because I'll need to put E and Z. We'll get to that in a second. So I've got a 6-methyl. And then it looks like I have 9. So 6-methyl. And it's not a non-ane, it's a non-ene because you have an alkene in here, right? So because you have this alkene, you have an alkene, you need to put the ene, you need to change the ane to ene. And so what we're going to do here is we're going to say where the alkene started. So it's a 5-alkene, right? So it's a non-5-ene. And I need to say where the ketone is. That is at carbon 3. So 3-one, right? Because that's where the ketone is. So that's where the one is. And you'll notice that I put the ketone at the end. And again, that's usually because that's the higher priority thing. So this would be a non-ene one, right? It'd be a non-ane without anything. It'd be a non-ene if it had an alkene, and now with a ketone also, it's a non-ene one, right? So this parent here is a non-ene one. Just write that so you can see the whole word, non-ene one, right? Whereas an alkene and a ketone in it, so it's a non-ene one, which is super weird to say, but that's what we call it. And then lastly, we do have an alkene in here with stereochemistry, so we have to say if it's E or Z. If you look at carbon 5, this has a higher priority group than just that H. If you look at carbon 6, the carbon 7 group has a higher priority than just the methyl, so these are on the same side, making this Z. So this is Z6-methyl non-5-ene 3-one. It's a mouthful, but that name would give you exactly that picture. That's the idea. And if I look at the last one here, I have a ketone with an alcohol. Again, ketones have a higher priority group than alcohols. And so I'm going to do my numbering in this case on the right-hand side. 1, 2, 3, 4, 5. And with alcohols in here, what happens is normally, right, you would have called an alcohol, you would have changed the ending to all. But here, because we have a ketone, the ending is going to be -one. So I'm not going to call it like an all-one or an one-all. What we do instead is that this alcohol group is now going to be referred to as a hydroxyl. It'll be a hydroxy group. So it's no longer going to be part of the parent because it's no longer the most important thing. We're going to call it a hydroxy group now because it's going to be a substituent. So we're calling it hydroxy as just a substituent. It's no longer the parent. And then I'll just name these groups as I normally would, right? Because I've got a hydroxy group, I've got a methyl group coming off of 4, and so I can name this whole thing now. So I would call this a 4-hydroxy, 4-methyl, 2-pentanone. 2-pentanone. And again, so normally with alcohols, right, we'd change the ending to OL and make that the parent. But in this case, hydroxy gets beaten out. The alcohol gets beaten out by the ketone. So we don't call it an all anymore. We don't call it like a pentanol or anything. We call it a pentanone with a hydroxy group on it. So this is a 4-hydroxy, 4-methyl, 2-pentanone is the idea. So if you have any questions about these, you can leave them in the comments down below. I hope you feel a little bit more comfortable naming the ketones now. Just change the ending to -one. Make sure they have the lowest priority group. That's basically it. All right, happy studying.